should be available. It should be free. That's why we have Wikipedia. That's why people think that Wikipedia is important. That's why open source software over the past 30 years has made such a map. The entire internet runs on open source software. This is not insignificant and small. This is something that affects 5/6 of the entire global population. So this is massive stuff, and I don't see this changing. I don't think that people are going to take this stuff away to change it. And so online there are amazing resources on how to do things. There's a fantastic website, instructables.com. People post instructions on how to do stuff. And it is anything from, like, there's a pretty funny one, like how to date for geeks. You know, so it's that obscure, to instructions on how to build these complicated things, to how to change out your alternator in your car, to how to make soap. It is how to do stuff, how to make things. Even more conceptual, like how to program. Like, there are instructables for this. Like, this is not even like physical hardware stuff. It's just, it's wide open. And kind of at the center of a lot of this is also the hackerspace movement that is starting. So we just did a panel on that, but I'm going to go over it as well. So hackerspaces, for those of you who are not familiar with them, are essentially community shared spaces. They run under a lot of different models. Some of them are nonprofit, some of them are open membership, some of them are closed membership with a trial period. You know, like there's tons of different models for hackerspaces. And hackerspaces, while all completely different, have one shared goal. It's to share resources, share knowledge, share information, and share that startup energy that's needed to do a project. You know, like there's always that amount of just inspiration that you need to go forward with something. Maybe it's self-initiated, but sometimes, you know, you see something that somebody else has, you're like, I want that thing. How much is that? I bought it for about $600. I can pay that. You know, it just changes your perceptions a lot. But the sharing of knowledge and tools are critical for that whole thing. So it's allowing people who've never done things before to get access to things like laser cutters and 3D printers. And these are technologies that are making impacts, solid impacts in how things are manufactured today, how things are progressing. The 3D printing has been around for at least 20 years. Longer than that in research, but like practically you could buy machines 20 years ago. There were 3D printers. They were astronomically expensive. But in the 60s, early 60s, we had laser printers. Astronomically expensive. Now, I bought a color laser printer a couple of years ago at Staples for $159 on sale. You know, it's just... Yeah, actually the ink was more than because I had to replace the ink because the starter cartridges were like a tenth of the density. So I ended up spending more money on my toner cartridges in the printer, but still, like, this is a technology that 30 years ago, astronomically expensive. 3D printers, when they first came out, you're looking at like $500,000. Even nowadays, they're like high-end wax printers and metal sintering printers, so you can print in stainless steel, and those are still around the $500,000 mark, but you can realistically get a commercial 3D printer for $30,000 to $150,000 and be printing in various forms of plastic. But you can build one for under $1,000 easily. The 3D printers have been a staple in the hacker spaces, but it's also part of this whole community because it is built on an open source project that is essentially a machine to self-replicate itself. So the RepRap project, you're trying to build a machine that can create copies of itself. That's pretty broad goal, you know, encompassing a lot of different technologies, but the strongest branch of it so far has been the 3D printing aspect, and they print in plastic. And they print in plastic because you can use the plastic as structural components. So you can print the braces for your printer. You go down to the hardware store, you buy $100 worth of rods and bolts and nuts, and you put this thing together from $10 of plastic $100 in parts, you throw in another $100, $200 in motors, and some more for controllers, and you've got a functional object that prints digital designs. And this is
what's interesting about that too is now everything is open sourced.
Yeah.
So if you want to make an upgrade to it, you just send out the information on how to do it, and you build your own upgrades.
And our so I've got MakerBot number 23. I was in the second batch that went out of the MakerBots, and she's been printing for like 2.5 years now. I've printed upgrades for my machine. It's functional at like a modern day one, and I've upgraded it consistently throughout the cycles. I'm not quite at like the new step extruder thing, so the latest revisions that they've just pumped out, I'm not quite there, but I'm printing really nice prints with the machine that I built with a group of people in our hackerspace 2.5 years ago. And it's absolutely the open source nature of this. I ideologically believe in it a lot. So a little bit of background for me. I'm actually a college dropout. I did not do well in high school. I was a straight D student, did very poorly, went to college, obviously didn't get any kind of scholarships because, you know, I'm pretty low grade. I did better in college, and I went for 5 years, and I had 160 out of the 120 credits that I needed. But I still didn't end up with a degree because they weren't pooled in the right areas. I just kept jumping around. I was like, oh, computer science, and there was all of these politics and theoretical. I was like, I want to actually do stuff, and they were like, well, it's just way too theoretical. It bored the hell out of me. Moved around to philosophy, Japanese, then I was in circus arts for a while, which is actually a lot of fun, but I didn't want a degree in circus arts. And then eventually the university was like, look, you gotta either shit or get off the pot, like seriously. And it's just, you're at least 2 years from a degree, and I was like, I've already been going for 5. I'm not gonna spend 7 years for an undergrad. I already owe you a lot of money in student loans, because like I said, I didn't have any stuff, so I quit that. The entire time I've been doing systems administration, like from the time I was in high school, I worked on computers, worked at a local computer shop, and all through college I was working for the Department of Motor Vehicles, like starting off as their low end, just computer tech, like whatever, I did call stuff, and then eventually got into servers, and you know, the entire time I'm getting certificates, like, which for me were like more functional. It was like I actually learned stuff during these processes. Like I learned how to do a thing. They were less expensive, and so like that's the route that I went. And then when I finally quit college, my friends who had gone through college got their computer science degree, and I was making twice what they were, because I had, you know, at that point about 8 years of experience on my resume, a bunch of certificates and things like that. And so I was a systems administrator for a while, and you know, you're like rebuilding your RAID array at 2 o'clock in the morning because it's crashed. This takes a while. So
15th time because management won't buy a new one.
The company I was working at was actually really good about this stuff. So the company I was working at before I quit was the best IT job I ever had, and it was passively acceptable. I did not hate my job. I thought it was okay. The things that were really good was that if you were off, if you were like on vacation, or it was not the time for you to be on call, they did not call you. Which, you know, I've had a lot of jobs. They're like, oh yeah, we've got this great flex time and all this stuff. Like, you only have to be on call 2 nights a week, so that means I'm on call 10 nights a week from like the amount of shit that you're throwing at me. So this company was actually very good. Respectful, they paid me very well, which I liked. But it wasn't awesome. And so I was doing a lot of stuff on the side. It finally freed up some free time. I managed to pay off all of my student loan debt and all that kind of stuff. And I started dabbling in electronics. It was a lot of stuff that I found interesting, like circuit bending. Like I had no idea, like no electronics experience. Didn't go to college.
Could you hold up your little device there so everybody in the back can see?
Yeah. So this is one of my kits, but this is one of my more advanced kits. This is not what I started with. There was a lot of failure between me and this. But yeah, I'll get to that in a second. So my first kit actually came about because, well, I've been doing electronics work. I've been working around, we did not call it a hackerspace at the time. It was before the larger hackerspace movement, but it was essentially the local Dorkbot chapter in Boston. We met up, we had like a constant space. It was sort of like an art tech gallery type thing that turned into something larger. So Dorkbot, for those of you not familiar, is a international organization. Their tagline is people doing strange things with electricity, which pretty much fits quite well. Like every single city has a different kind of Dorkbot. And it's so informal that I can declare that I'm the Dorkbot overlord and we are having a Dorkbot meeting right now. The only requirements are that it's free and open to the public, and that you have some kind of internet presence announcing like what you're doing, allowing discussions and things like that. Beyond that, you can be an official Dorkbot chapter anywhere. So we had a pretty active Dorkbot chapter in Boston. And I moved to Boston because I knew some friends there, and I was like, Boston sounds nice. I'd never been up to the Northeast. I grew up in the South, in Louisiana, and I was like, okay, that sounds fun. So I went up there and got involved with them, and a lot of people there were working on electronics. I was like, this is really cool stuff. And you know, I by that point subscribed to Make Magazine, and I was reading the RSS feeds for Make and Hackaday and a bunch of other websites that were covering a lot of the stuff that was being made. And I got into circuit bending because a lot of my interests are audio-based and doing sound type stuff. So circuit bending is the modification of toys and synthesizers and effects pedals, basically anything electronic that makes noise, you add additional controls and do things to. So I started teaching some classes on how to do that, how to build the Atari Punk console, which is a name for a simple synthesizer with a dual 555 timer chip in it. And then Instructables had a contest for Valentine's Day, and Get the LED Out, so Get the LED Out contest. And they had them simultaneously, so I decided to just double up and do both of them at the same time. So I created, I've been kind of fascinated with like LED matrices and like how they drive, because you're not driving all of the LEDs simultaneously, you're actually driving banks of them, the same way that LCD monitors and televisions kind of do a scanning type thing. Same thing, like this is, it looks like there's a lot of LEDs on at one time, but if I shake it, you actually see the dots. So that's the pulsing of the actual image, and that fascinated me. I built like a little 3x3 LED cube, and I was like, this is amazing. And I ran across this technique called Charlie plexing. I'm not going to go into depth here because it melts people's brains. It's kind of absurd, but it's a method of driving a lot of LEDs with very few pins of a microcontroller. And I was like, okay, it's Valentine's Day, I'm going to build a heart. So I built a little heart, I did Charlie plexing, it allowed me to drive the 27 LEDs with 6 pins of the microcontroller. I had started doing some microcontroller work with the basic stamp and then the parallax propeller chip, and then Arduino started to like make waves, and they came out with their first board with the USB on board, and I bought one in 2006, something like that, so I started like screwing around with that. Having gone through computer science for 2 years, I had some background in programming, like I knew how to program, I just didn't want to do it for a living. So I built this heart, and a lot of people in Instructables were like, we would like to build this too, can you make one for us? And I was like, this took me like 4 hours, there's no way I'm soldering this, because it's a very complex matrix of doing it. So I decided to just give my hand at making a circuit board for it, a printed circuit board. So having the design laid out in copper on a board, and what the hell? I'll throw $1,000 at this just to make a kit, see how it goes. If it takes me 2 years to get back my money, that's fine. I don't care. Do not care. And I came out with the thing, and then I went to an Ignite Boston event, and some folks from Make were there, because it's an O'Reilly event, so Make is part of O'Reilly. And they were like, this is really cool, you should come down to Providence at ASU 20. We have this guy, Mitch Altman, as the artist in residence. We're doing a thing this weekend. I was like, oh yeah, I've actually built something. So Mitch Altman, he's the inventor of the TV we got. And he got involved in the hackerspace culture. Like, he came from the traditional engineering style. Like, you patent your devices, you fight for them, and you work for a large corporation, you do all of this stuff. And then he ran into the German hackerspace movement and saw what they were doing with open hardware, and he open sourced his designs. So he took his commercial products that he was actually selling in the store. The TV gun is a remote control. You can buy it. Like, they were selling it at Target for a while, but you can buy it online for sure. And he open sourced those designs. Now there are kit versions of them you can build. So I met him while he was at AS220, and essentially him and all of the folks there ganged up on me, and they were like, you should just quit your job and do this, because you're very passionate about doing this. You're very passionate about teaching people. Why don't you just do that for a living? I'm like, I don't know. And they're like, okay, look, Mick said if I would go down to Maker Faire in Austin, they would buy all of my kits. Because I was like, yeah, I've got like 200 of them left. They were like, okay, we'll buy all of those if you fly down to Austin for Maker Faire. And I spent the entire weekend teaching people how to solder and build kits. And I was like, this was amazing. I worked 14-hour days, and I was thrilled by it. Like, I was energetic at the end of the day. And like that kind of spoke to me. I was like, okay, this is, wow, that's awesome. Essentially, it paid for a vacation for me to go to Austin, and I had a hell of a time teaching people to do stuff. And so that kind of like, that ignited a fire, so I started teaching more workshops to local hackerspace and with surrounding area hackerspaces. Then Mitch talked me into going to Chaos Communications Congress in Berlin. So it's a large hacker conference. It's second to DEF CON as far as the size goes, where you've got 5,000 hackers in Berlin for 4 days making things. And I went there, and it was a legitimate life-changing experience. I brought a handful more kits. I had a few other projects. I was teaching circuit bending, and essentially, it paid for a chunk of what I was doing. Like, I ended up spending 10 days in Berlin, and with what I sold, I basically spent like $200 on a 10-day vacation. That's the way I saw it. But once again, teaching people how to do this, I actively enjoyed it. And I resolved there to, by the next year, be doing that full time. I only had one kit, and I almost paid for a trip to Germany for a few days. So over the next 10 months or so, I ended up coming out with my second kit, which was the Atari Punk console. It's that simple synthesizer that I was building before, but nobody had like a circuit board that I liked, so I designed a circuit board for me and my friends. We started making them, and then I started running workshops locally. I was like, well, screw it, it's open. So like the circuit design is from '81, like it's in public domain as far as electronics are concerned. Horace Mims did the original circuit way back when. So I did a kit, and then that was a big seller, huge seller. And that was almost getting to where I needed to be for like making my base living expenses, paying rent, paying cell phone, paying all that kind of stuff. And then with the workshops that I was teaching, I realized that I could make a living continuing to do this. And this is what I did over the course of like 2 years. This is not like a skill that I was taught. I just learned it by doing it over a couple of years. And it was because of the people, the spaces, the events, and all of the stuff that's happening right now. It was the ability or the availability of the information that's online. So after I quit my job, I'm laying in bed. I need to get the second revision of the Open Heart out to the manufacturer so that I can get them in time for Valentine's Day. We'll get a test version of it, a prototype, check it, and then make sure that it's good for doing Valentine's Day, because Valentine's Day is a big one for the Open Heart. And I'm procrastinating as I do. I'm actually pretty lazy about doing stuff, but all of my best projects have come from me not trying to do something else that I should be doing. And so what quitting my job allowed me to do was lay in bed and think, how many LEDs can I put on a circuit board for the Arduino? So this is just an Arduino shield. This plugs right in. And since I already had the CAD software open up on my desktop, I just got up out of bed and I started like screwing around. I downloaded the Adafruit proto board design. It was open source. Downloaded it, deleted everything out of the middle, and then started popping LEDs down. And I was like, 14 by 9. Okay, that's gonna take 12 pins of the microcontroller. Oh shit, that's both of the serial pins free and all of the analog pins free. So you can still do stuff with this after the display. I was like, this is actually a kit. And I sat down for 12 hours, worked out the PCB design. I'm a bit OCD about stuff. Like if I allow myself to get into a mode, like I just really obsess about it. It's why I banned myself from video games for the year, because like I will seriously do something for like a week solid. Like I allow myself to do it, just focus. So I did this entire layout, and in 12 hours, and that evening, I went ahead and put in 50 of these circuit boards in with my order for the open heart boards, the new version. So I went ahead and got everything all at once. I got the boards in 2 days before I left for my second Chaos Communications Congress, and I went ahead and bought a bunch of the LEDs, all of the LEDs out of Mauser that they have this style. So it was enough for 50 kits total. So I bought Mauser out of LEDs. And now, like, I can't even go through Mauser. Like, I'm on the 6th, I have a delivery of 112,000 LEDs coming into my apartment. Last year, I did a third of a million LEDs. So, like, it's just sort of like, it keeps scaling up. And when I got there, once again, like, this is a completely open source project. I'd already posted the boards online. I'd already posted the schematics. Within a couple of hours, I wrote the very basic software based off of my open heart code. Horrifically inefficient. Yeah.
Mauser?
Yeah, so Mauser...
M-A-U...
Yeah, M-O-U-S-E-R. Yeah, so Mauser is a parts distributor in the United States, so they sell like base components like LEDs, resistors, capacitors, chips, whatever.
Well, I got a project right now I'm working on that I was trying to figure out where I was going to come up with IR LED.
Yeah, Mauser, DigiKey.
They're like what Radio Shack used to be.
Yeah.
Well, Radio Shack was never even like as large as so in DigiKey you can get anything that's electronic. Mauser has a slightly lower selection, but they have, on some cases, better prices. DigiKey is like, you get the really good prices at like 10,000 quantity, whereas a Mauser, like, you don't get that price until you get 10,000 quantity, but at 100 quantity, they're willing to go a little bit lower than what the DigiKey is willing to do. So they're willing to do smaller.
You guys go to Mauser, make sure you sign up for just do their account thing, because they've got these project sections where you can just say, I want to make like Jimmy's project up here. You order the parts and it stays within that.
Yeah.
You click and I want to make 10 of these. So it'll automatically put all 10 parts.
Yeah, they do a bunch of freaking awesome stuff. Yeah.
It's awesome.
Yeah, so I showed up to this hackathon, and because my project was open source and it was crappy, people immediately signed on. I don't know what they're like, oh wow, something, this looks like a project. And by the end of the 4th day, like I had a full library, scrolling text, like it was 4 times brighter because people had not only like made it more efficient, they started using timers and like all of this stuff. And I learned so much. It took me like a month to figure out what the Germans had typed up. It was like, what is this? And it took me another 2 months to understand the math, because like the math behind this is obscene. Like it gets really, really crazy.
Jimmy, I was just gonna say, I mean, you walked into that hackerspace like with no software for this cool hardware. I mean, you would hack up a little bit, but
Yeah,
it was
I-
like no code when you arrived. And
Yeah, exactly. It was very dim. You could address all of the LEDs individually, and I had one test program that would scroll, swipe across this way, and then swipe across this way. It's the same test pattern I use now, but very basic, very simple, but it worked. And yeah, the point of all of this though is that this right here, I've sold almost 3,000 of these kits within the year. And that is $25 retail for red or blue, and then the green and white, or sorry, the red and green are $25, and blue and white are $35. And so I followed the Lady Ada pricing model. That's 2.6. Whatever your base costs are for actually producing the kit. So that is getting the parts, putting them in the bags, everything. You multiply it by 2.6. And what that allows you to do, this is the important part, is that it allows you to have a margin for retailers and a margin for yourself. And the reason why this is significant is 90% of all of my sales are through Make and through SparkFun and through Adafruit. They sell more of my kits. They order them by the hundreds at a time. And I will sell, 50 kits total during the course of this con, 50 to 100, and like half of them will be my wool shields. So it's just sort of like I sell a chunk of them here. Like it's sometimes enough to pay for the con. In this case, I'm a guest monitor, so I get paid for. So that's nice. I won't lose money on it this year like I did last year. But yeah, so. Essentially, my $25 roll shield kit, I sell it to Make or Adafruit for $15. So they're getting their 40% margin. And then it costs me around, initially when I did them first in the low quantities, it was actually costing me about $9.50, but through just massive bulk ordering of LEDs, and also once I got the prototypes for the circuit boards down, and now I'm ordering them 2,000 at a time, like that really dropped the price. So now I've shaved off, and it's closer to like $7, $6.15, depending to get one of these made. So I'm like making a couple extra dollars on it, but still kind of maintaining the price. So like I'm making pretty decent margins, so it allows me to like drop them sometimes if needed. But this is important for people who make things and sell things. Like, you can't underprice yourself. You are doing something physical. Like, if you are trying to actually make a living doing something, if it's a hobby and you just want to keep it as a hobby, and you want it to pay for itself, you still need to make money. There still needs to be a profit generated, because it's not sustainable, because there's extra costs that you never like see going. Like, I spend $2,000 a year on shipping. Like, really, like, it's just, these are like costs that get built into other things. I spent getting stuff here to Penguicon like $70 in shipping, just getting things here. That's just for this one con. So like these are costs that people tend to overlook, which is where a lot of that margin gets eaten up, and so you have to price it decently. And 2.6 is acceptable with the community. People know what it is. And if you went out and bought the LEDs, especially these blue LEDs, like I charge $35 for this kit, but you go online, you buy one of these LEDs and they're $2. And if you buy the 133 LEDs, they're still 50 cents a pop. Like, it's cheaper for you to buy my kit with the crap ton of LEDs. And the only reason I'm getting that pricing is because I'm ordering 250,000 LEDs a year from a manufacturer in China. I'm even having them custom manufacture my LEDs to fit my specifics. And when you're willing to say, I will give you $5,000, can you make this thing for me? They say, yes, absolutely. Right away, Mr. Rogers, we have that thing. They don't have that thing. They make it for you. They never, ever, ever say no. They never say no. I went on a trip to China, as I said earlier, and saw a bunch of factories, and like that really put in perspective like how to get things manufactured. And basically, I have a few people that I email now. It's like, I need this thing. This is the price that I'm looking for. Can you meet this price? They'll say yes or no. And sometimes I'm like, I need this thing. How much can you do it for? It just depends on if I have like a set value of mind or whatever. So yeah, it's kind of mixed. But like I said, I do electronics, but a lot of the stuff is honestly, it's basic business. It really comes down to basic business. So there are a handful of like multi-million-dollar companies now that are doing open source hardware in electronics. So SparkFun last year did $15 million in sales. This is a private company. 100% of their intellectual property rights are following the open source hardware definition. So you can download the files. You can actually even order it through their PCB service and sell the kits from their PCBs that you're buying from them against them. Part of the licensing. Hilarious to me. But in practice, what it means is that they are supporting the community, and people in the community are improving the project. The Lol Shield would be nowhere as popular as it is if I did not have Tetris. And I did not write Tetris. Tetris is one of those crazy Germans. And so I have Tetris, I have scrolling text. Like, honestly, when I say that I'm lazy, it's more like I get bored as well. Like, I will become very obsessed with something until I've solved the problem that has plagued me. And then after that, it's like, okay, well, if I finish up like these few polishing things and really make this thing nice, oh, what's that? How does that work? I don't understand how this works. This is hard. And so that's my next project. But people in the community really, really picked this up. They continue to improve the efficiency. The algorithm got improved again. Now I no longer understand how it works. It's like, I do understand. But it took me, once again, it was like, okay, now what the hell? You're doing completely different weird math. It's compressed it so it's using less memory, like a bunch of other, like, basically like a hardware developer who's been doing microcontroller work for a long time sat down and was like, oh, why are they doing it this way? It's like, obviously you should be doing it. It's just applied some best practice, and now my project is better for it. Yeah, so yeah.
Oh, so you mentioned you went down to Austin. I'm just interested in that area, and it's like the Silicon Valley of the Texas or whatever. I'm just interested in your take on what it's like down there, and for makers and.
So I grew up in West Central Louisiana, so we'd actually make kind of weekend trips out to like Houston and Austin. Austin is about the only redeemable city in the entire state of Texas.
You might as well include Oklahoma in the same mess.
Yeah, and Louisiana as well. I mean, like, seriously.
I still think modem's what you do to them dar yards.
It's my experience with Austin as far as like being a maker culture though is pretty recent, and that was the last year that they had the maker fair down there. So I go to all the maker fairs, but funding fell through locally for it down there. Like, none of the business got on board again. Even though they have 45,000 people show up, apparently that's not enough for their civic center because rodeo pulls an 80. So it was just not enough to be viable for it. So they could probably pull it off again in Austin, but it was kind of new. Like they'd only done a couple of the San Mateo maker fairs, and it was still very, very new. But there's a lot of stuff going on in Austin right now. Everywhere in the United States, though. Like, it's universally everywhere, even in, well...
Even in Indianapolis.
Even in Detroit. Oh, gosh.
There's a lot of stuff going on in Detroit, but, I mean...
Well, there is in Detroit. There's not in Indianapolis.
Didn't start a hackerspace.
I tried. I should say, I'm trying.
Yeah. I mean... The things that I've seen like being really successful is like the Dorkbot chapters, because that's low cost of entry as far as like just participation, and usually you can pull members from it. It's building up community. I mean, hackerspaces are, I see it as most importantly is community. That's the most important aspect of it. Yes, sharing resources, yes, sharing tools, they're fantastic, but without the people, it just doesn't make very much sense. Like, without being able to meet people, being able to do stuff. So. The other thing that's fantastic though is people have, like, everybody has access to